Hi there, welcome back to this channel. This is the first video in our calculus series, calculus, and you see, I'm very excited to introduce you to this topic. But you see, in order to understand calculus, there are a number of topics that we're going to be taking, which are fundamental for understanding calculus. There are functions. You must understand functions. You must understand lines, equations of lines and triangles, and the rest of that, but basically equations of lines. You must also understand limits and continuity. Limits and continuity. Now, understanding limits and continuity, if you understand these three at least, then you can go into differential calculus, and integral calculus, and then the applications. And this is the way we are going to take all of take the calculus course. We're going to be beginning with functions today, and then lines later on, limits and continuity. You see, if you go with this series, you're going to have a good grasp of calculus. Otherwise, calculus is going to be a set of rules that you will have to cram, and wouldn't make sense at the end of the day. So let's start with the functions. Now, what is a function? I'm going to be giving us two definitions. The first is an informal definition. Informal definition. We can define function informally as, think of it as an operator like a machine that can transform a particular entity into another thing. So, for example, I can work on a particular raw material and transform it into another thing. So the machine that actually transforms that thing into another thing is what a function is. All right. So, and that material is a variable. The material that we'll get is a variable. The raw material is a variable, the product. So think of raw material, and think of product. So raw material goes on to product. So this arrow is the machine that converts this raw material to product. So this is going to be what? Our function. This is going to be our function. And so a function is basically an operator, is that okay? Or what transforms something that transforms a relation, is that okay? That transforms one thing to another, is that okay? That's an informal definition. Now, mathematically, we define a function as a relation in which every value, every element in the domain, so there is a domain, has an exactly one image in a codomain. A relation. So basically, it's a relation that gives every element in a domain a value in the codomain. All right. So, for example, if I told you, now this is the way it is written. We have f into bracket x. Now it is read f of x. F of x. That's the way it's read. Now, if I have a value like this, if I have this function that says 2x minus 3, for example. Now, what this says is that, what this thing means is that from the informal definition I gave you is that this is a machine, for example, that converts every x that I plug in into a particular value, which is my new variable. So we will call this, usually in math, you will see this represented by y equals 2x minus 3. So that f of x is the same as what? The same as our y value. Do you understand? So x can take on any variable. So, but for y to take on a particular variable, it depends on x. So that is why we call x the independent variable, and we call y the dependent variable. Why? Because the x variable can take on any value, while the y variable needs the x factor based on this relation to have a particular value. So if I take my range of value, so inside my set, for example, inside my set A, I say I have the following values: 2, 2, 3, 4, maybe 0, 2, 3, 4. I have all these values for my A. And in my, so let A be my domain where I'm picking values for my X. So A is my domain, I'm picking values for my X. Now B will be my codomain where I have values for my Y. Now for us to have a particular Y value, I have to plug in any particular X value here to correspond to achieve or get a Y value out. So for example, I'm going to plug in the first value of X there, which is what? 0. So I'll have that since f of X is this, is 2x minus 3. So now f of 0 will be what? That is when X is 0. Is that okay? It's just as simple as it is. You plug in 0, 0 here, and you have 2 into bracket 0 minus 3. So 2 by 0 is 0 minus 3. So we have, well, our answer is what? Minus 3. So our f of 0 is what? Minus 3. So we have minus 3 here. That's going to be our first Y value. Do you understand? So what happens is that this guy actually transformed 0, this operator, is that okay? Transformed 0 into something new. All right, let's work on f of 2. Now, if x is now 2, we have 2 into brackets 2 minus 3. So we have 4 minus 3, which is 1. So we have 1 for our 2 value. And then f of 3, we have 2 into bracket 3 minus 3. So we have 6 minus 3, which is what? 3. So that is going to be what? Our next Y value for what? When X equals 3. Y is also 3. Now, when we work on 4, f of 4 now is going to be equal to 2 into bracket 4 minus 3 is 8 minus what? 3. And that is 5. That is 5. So what do we have here? This shows us that there is a particular machine that can transform every element here into a specific value in the other place. In this place, into a specific value here. And this place is called our domain. This place is called our domain. That is where we are picking our X values from. And here is called our codomain. It's called the codomain. Now, all of the elements here are called images. They are called what? Images. These values, they are called images. What does that mean? It means minus 3 is the image of 0 in set A, and 1 is the image of 2, as 3 is the image of 3, and 5 is the image of 4. Do we understand that? Right. So that is the brief introduction to functions. Now, there are now many other things we could now do with functions. There's something called, now we have different types of function. We have different types of function. We have different types of function. Now let's talk about, in terms of the Cartesian representation, we have functions. The function can either be linear, such as the one we just gave, the example we gave, that was f of x equals 2x minus 3. So this is a linear function. And why is it a linear function? From the word line, meaning that it gives rise to a line when we plot a Cartesian of this guy. X plots a graph, that's what I mean. If we plot a graph of this guy, we're going to derive what? A line. So that is called linear. Is that okay? So linear function. We have a linear function. Then the next function we have is the quadratic function. Quadratic function. Now, another thing about linear function is that the highest power of x, which is our independent variable, is always 1. So x is raised to power 1 here. Is that okay? Then for quadratic function, the highest power so let's use another function now. Maybe that will be g of x is equal to x squared minus plus 2. So the highest power of the unknown here is going to be 2, and that's why it's called what? Quadratic function. Then the third type of function, according to the Cartesian representation, is the polynomial function. A polynomial function is basically, so we have trinomial if the highest power is 3, and we have quadrinomial if the highest power is 4, and like that, like that, like that, like that. So that is what we have. So these are the sets of functions that we have. And they are named this way because of their Cartesian representations. This guy is going to give us a line. A quadratic expression will give us an upward facing parabola or a downward facing parabola. That is a cup or a cap, you know, if you've done quadratic equation before. We've actually, I think I covered a short video on how to go about quadratic equation, but I'm still going to do a full explicit, an explicit video on quadratic equation, and I'm going to post them. And so if you have not already, do subscribe to the channel so that you will not be, you will not miss when I post those contents. All right. So let's continue. We talked about the type of function according to the Cartesian representation. All right. How about the types of function according to their relationships? So for example, I could have 2 or more functions and relate them together. So I could have, for example, a composite function. I could have what is called a composite function. Now, a composite function basically means a function in which other functions can be plugged into. As in, it is a function from which I can derive another function or put in another function to get another function. Composite simply means used for diverse things. Is that okay? So, for example, there's something called composite demand, so which means that I could demand flour if I wanted to make cake or bake cake or bread or all of these snacks. You understand? The same flour is used for all of those things. Is that okay? Sugar also has composite demand because it's used for a variety of functions. So when something serves many functions, it's called a composite. It's called composite. Is that okay? So this guy, the composite function is one that adopts other functions. Other functions can be plugged into it to derive another function. Is that okay? Okay, so for example, let's use these 2 functions. For example, let me generate a third function. Let's say h of x. Now, these are notations in mathematics that we use. We use f of x, we use g of x, and we use h of x. Is that okay? So now I'm not going to be introducing a trinomial here. I'm just going to use linear, quadratic, and another linear. So let's say we had 2, I love 2x. Let's use just x plus 3. All right. So if this was, so f of x is 2x minus 3, g of x is x squared minus plus 2, h of x is x plus 3. And remember, since they are different, this means that these are different machines or operators that work on x to give different values, and that's why you see them being lettered differently, g, h, and f. Is that okay? So it means that if f works on, if we have f of 2, we will get a different value from when we have g of 2. Is that okay? All right. But that is not our focus here. Our focus is on composite function. If I have something like this, f of h, what does that mean? I could be given to find g of f. I could also be given g of f of h. Now, I could also be given f of g of h. I could be given in any way. Is that okay? So let's quickly just work on this 4 and proceed to the next stage. Now, for a composite function, I could have f of h. Now, what does f of h mean? This can be rewritten as f of, now I'm going to be using a square bracket first, f of h of x. Why? Because this is saying f of h, meaning that I'm going to plug in my h, which is a function of x. I'm going to plug in into my function f of x. Do you understand? Let me explain further. Now you see h of x is x plus 3 and f of x is 2x minus 3. It means that my x value for f of x, my x value will now be the function h of x. So the function h of x will represent my x. Function h of x is what? Is x plus 3. So I'm going to be plugging the entire x plus 3 into 2x minus 3. Is that okay? So it's going to become 2 into bracket. Anywhere I find x, I'm going to sub into x plus 3. then minus 3. Do we understand? What I basically did was I brought down my f of x. F of x is 2x minus 3. But now I'm looking for f of h of x. H of x is this. So I plug in this into x position. So I have 2x plus 6 minus 3. So we have 2x. This minus this is what? Plus 3. And so f of h of x is what? Is 2x plus 3. All right. And that's that for that. Now let's go to the next one. G of h. G of f. Now what is g of f? G of f will be, now g of f will be equal to, now my g is x squared plus 2. So the same way, anywhere I find x, I'm going to plug in my f, my function, the entire function f. So that is, this is g of f of x. Is that okay? This is how to write it. Another way to write it. So g is x squared. Recall that g of x is x squared plus 2. So anywhere we find x here, we're going to plug in this entire function so that we have 2x minus 3 all squared plus 2. That is g of f of x. Do you understand? All right, so let's square this. So we are going to square it, minus 3, 2x minus 3. So all of this plus 2. So this by this is going to give us 4x squared minus 2x times 3 is going to give us minus 6x minus this minus 6x again. Then minus 3 times minus 3 plus 9. Is that okay? So that we have 4x squared minus 12x plus 9. Then plus 2 now. To bring down our plus 2. So this plus this is going to give us what? 11. So we have 4x squared plus 12x plus 11. And this is our g of f of x. All right. So I hope that is clear. Okay. So I'm going to come back here and solve. Let's work on g of f of h. G of f of h. So now, this is composite of one function. Now this is now composite of two functions like that. This is composite of two functions. Now, this is now a composite of three functions. I have three functions in here. Three functions, g of x, f of x, and h of x. All right. So I'm going to be, so the way you do it is you start from the back. This means that we're going to plug in the value of f of h of x. We're going to plug in the value of f of h of x into g of x. This means that the value we got for f of h of x, and I think we've done that before, f of h, we've done that before. I think we got 2x plus 3. 2x plus 3. So, but we'll solve it again. So first, we are going to do f of h of x. So f of h of x first is going to give us 2 into brackets x plus 3 minus 3. Okay, so 2x plus 6 minus 3 and 2x what? 2x plus 3 will be f of what? H of x. Now this is our answer for f of h of x. So we will now plug in this function into g of x. Remember that g of x is x squared plus 2. So we're going to square this value. 2x squared plus 3. 2x plus 3 all squared. So this will be g of f of h of x. Is that okay? So this is it. All squared plus 2. So what do we have here? Let's square this. This square is going to be 4x squared, 3 squared, and 3 times 2. I don't want to use, I don't want to put two brackets again, so I just want to expand directly. This times 2, 6 times 2x is going to give us what? 12x. Is that okay? Then plus this squared is 9, then plus 2. So what does that give us? This gives us 4x squared plus 12x. This is the same. Oh, okay, there is a mistake here. This is minus. This is minus. All right, minus 12x. All right, so what do we have? we have this plus 11, and that is our g of f of h. Is going to be this function, right? This quadratic function. All right, let's go for that. Let's solve for, what if we ask to find, okay, the last one, which says f of g of h. F of g, okay, in fact, I'm not going to be solving this. I want you to post the answer in the comment section. Find f of g of h. Find it. And I'm going to, like each of the comments that gets the answer. Is that okay? So you can try that on by yourself. Work on it. F of g of h. All right. So, and if you have not until now subscribed to the channel, do want to subscribe to the channel in order to help the channel as well. Be notified whenever I drop new content like this. You see, in this channel, we help you understand science and not just cram it. Is that okay? You understand it. So by understanding, you don't get stuck. You don't get stuck. All right. So the next function, which will be the last function we're going to be discussing, will be inverse function. Inverse function. Now these are two types of special function. We discussed composite and inverse. So those are two types of special functions that we have. So for inverse function, an inverse function, let's use our f of x that we have there. F of x is 2x minus 3. Now an inverse function means f inverse of x will be what? Now an inverse function is very simple. You remember that I said, this is just the notation here. Remember that I said that f of x is the same as y, so that y will be equal to what? 2x minus 3. So what you want to do to get the inverse of this function is this. To get the inverse of this function, what you want to do is that you want to make x the subject of the formula. So when you make x the subject of the formula here, you're going to have 2x will be equal to y plus 3. Is that okay? So you divide both sides by 2. You have x will be equal to y plus 3 all over 2. Now this is what looks like the inverse function, but because it is a function of x, what you want to now do is that you change this value of this y, you change it back to x. The reason why you are changing back to x is this. What an inverse function does is that while the forward function, the actual function, gives you a y value, the inverse function gets you back your x value. Do you understand? That is the use of this inverse function. While your f of x will give you a y value, your inverse function derives back for you your x value that you initially had. So you now say that f inverse of x, which is now this, is equal to what? X plus 3 over 2. And this is an inverse function. And how do we can test that? So for example, if here we had f of 2, what would f of 2 give us? F of 2 would give us 2 into brackets 2 minus 3. That is 4 minus 3, and we have 1, right? So if I were to look for what I started with, my x will now be this 1. So if I plugged in the value of 1 here, let's see what will happen. F inverse of x will be equal to 1 plus 3 over 2. That's provided we have the y values, okay? So 1 plus this is equal to 4 over 2, and that's what? 2, which was what? The x value that we started with. So that is the use of inverse function. All right, now let's now work some maths. Let's enjoy ourselves. I want us to do some things like let's make composites and inverse. Let's make composites of inverse functions. So what if I said, give me g inverse of f of h of x. So what if you're told to do this? So the first thing you want to do is you want to get what g inverse is. All right. So remember that g of x is equal to this, x squared plus 2. From there, so what do we have for g? So let's make g of x. Let's make it our y now, x squared plus 2. I'm just making it a particular y, or maybe let's make y prime. Since we've made f of x y the other time. So let's make this one y prime, so that we have x squared will be equal to y prime minus 2. So x will be equal to the square root of x of y prime minus 2. So in order to make it our inverse function, g inverse of x will now be equal to, we change this to x square root of x minus 2. All right. So how do we now resolve this? How do we resolve this? We will now find what is f of h of x. So what is f first of h of x? Now f of h of x is going to give us, that's f of h, is going to give us 2 into bracket, we plug in h. Okay, we did it the other time, we got 2x plus 3. 2x plus 3. So this is f of h. So we are going to now find g inverse of this. So we just plug in this value into this equation and we have g inverse of h and g inverse of f of h of x will be equal to, you know, the brackets has to be complete. This is the bracket for this one, this is the bracket for this, this bracket for this. It's equal to this is our g inverse now. So we plug in this value into this place so that we have square root of 2x plus 3 altogether. That is our x minus 2. And this becomes the square root of 2x plus 3 minus 2 outside now. So we have 2x plus 3 minus 2, that is what? Plus 1. And that is our answer for g inverse of f of h. So that is the answer to this. And that will bring us to the end of the video. But before we go, I would like you, in order to ensure that you've understood the concept, solve these two also and post the answer in the comment section. I'm going to like the first to post the answer. All right, so find for me h inverse of g inverse of f of x. H inverse, let's make this a curly bracket, a square bracket. All right, so find this and find this second one. So find H inverse of G inverse of f of x. All right, find f inverse now of G of H inverse of x. All right, and post the answer in the comment section. So the first one is to find the H inverse of G inverse of f of x, and now find f inverse of G of H inverse of x, and post the answer in the comment section. So I'll let you know if the answer is correct, and do well to subscribe to the channel, share this content with your friends, and like the video, and God bless you as you do so. See you in the next video.